Good afternoon, everyone. I think we've got a few people still in the waiting room, actually, so I'll just wait for them to come in. Hello, everyone. Really nice to see you. I'm Charlotte from the Green Register. I've got Elaine with me, and we're really happy to introduce Lawrence Glennon from Lowie Bricks. So Lawrence is going to be talking about, well, it's entitled The Sustainable Brick Revolution. So he can tell you much more. A few housekeeping things, the usual stuff. So if you wouldn't mind keeping your mics off until a bit later on after the presentation, we can open up for questions. Do pop your questions into the chat if you'd like to. While Lawrence is talking, you might think of things or you might want to share something as well. And yeah, there's just a couple of upcoming events here on the slide that you can see. We've got quite a few things coming up. So tomorrow we kick off with retrofitting traditional buildings. That's actually a three-part series. So it's part 1 and 2, and then there's a case studies element as well in the third part. We've got on the 30th of June regenerative design. 1st of July, we've got a stone demonstrator. So if you are interested in bricks, you might also be interested in stone. So it might be a good one. If you're not already a member, then please do consider joining us as a member. There's the link just on the slide there, but also head to our website if you'd like to become a member. You can get discounts on training fees and lots of other good stuff. We've got some free courses actually for members now as well, introductory courses, which might be useful. They're sort of pre-recorded ones. I think that's probably about it. If you wouldn't mind just, if you haven't got the name that you signed up with on your Zoom, please just add that just so that we know you're here and we can sign you in. But yeah, I think that's probably about it from me. I'll stop sharing my screen and allow Lawrence to share his. Thank you very much.
Thank you very much, Charlotte, and thank you everyone for joining the session. Hello, my name's Lawrence Glennon of Lowie Bricks. I'm just going to share the presentation with you guys now. Hopefully that you can now see the brick revolution. The talk should run, as I say, for about 20 minutes, leaving plenty of time for discussion and any questions anyone may have. Really, we are Lowie Bricks UK, and we would like to welcome you to the Brick Revolution. As I said, my name is Lawrence Glennon. I'm the specification manager for Lowie Bricks. I have been in the brick industry for about 12 years in total, initially as a logistics manager for an importer, and then moving into specifications. And when the opportunity came to work on Lowie Bricks, looking to reduce embodied carbon in facing brickwork, that was very much the most exciting thing that had happened to me since my time in the brick industry. So brick production methods have barely changed for thousands of years. So we don't think we're being grandiose by describing this as a revolution. But I guess that's really for you all to decide once you've heard the presentation, really. Lowie is pronounced like Zoe because it stands for low impact on the environment. We get called Lowie quite a lot. We don't mind that. Lowie, Bowie, but it is technically Lowie because it's low impact on the environment. Bricks have an excellent life cycle, and this durability already puts them in the sustainable materials category. But with its energy-intensive firing process, there is the potential to significantly reduce production emissions. Lowie Bricks are the result of a research and development program launched in 2019 to find sustainable and affordable alternatives to classic facing bricks. By a process of extensive experimentation with different materials, we've managed to preserve the aesthetic and qualitative characteristics of clay fire bricks with a fraction of the carbon emissions. The bricks are mineral-based, consisting of a selected range of very fine sands, a binding agent, and then small amounts of water. We mix these ingredients together, and at this stage it's a sort of semi-dry matter, which is then added to a mould. That's then compressed under immense pressure whilst vibrating. And this pushes all the air out, forces the mineral and binder to interact and assure for strong and optimal bonds. Curing of the bricks is fast and needs no additional heating due to the exothermic process. We then apply a finishing layer to the bricks to give them their authentic look. It's a radical innovation in brick production methods that preserves the classic clay-facing brick look that we all appreciate. Lowie Bricks, an entirely new category of building material. RC certification and declaration of performance are categorised under both ceramic and concrete standards from EN 771. So specifically, that's 771-1 for clay masonry units and -3 for aggregate concrete masonry units. But the bricks are neither clay nor concrete. And the reason that we've got this dual categorisation is we've achieved the key technical properties of both types of brick. We have already been granted a patent in Belgium, and we've just had confirmation that we've also been granted the patent for the UK and the wider EU, with over 200 completed projects in Belgium, multiple mid-construction and some now complete in the UK as well. We are already well beyond the conceptual stage. This is very much already a reality. We believe that real ecological progress is only possible if it is also affordable. Lowie Bricks is sustainable, affordable and authentic. How sustainable are they really? We commissioned a rigorous life cycle analysis, which shows that the bricks can currently offer up to an 81.3% reduction on carbon emissions when compared to soft mud clay bricks. And they still come with that same fantastic service life, having achieved the highest category of durability rating, F2. The life cycle analysis, from which all figures quoted in this presentation are taken, includes the embodied emissions of the binding agent, which itself is a byproduct of steel production. If these emissions were not counted, then due to a process called carbonation, Lowie Bricks would actually be carbon negative. We'll talk a little bit more about that in just a moment. Another concern we sometimes encounter is that sustainable products make aesthetic compromises in order to achieve their environmental credentials. Excuse me. We believe this is unnecessary with bricks. The fine and monotonous materials used in Lowie Bricks makeup, coupled with an additional finishing phase, guarantee an authentic clay brick appearance. But the biggest or most common objection we ever face, how much? So many sustainable products are brilliant ideas, but they're never going to make a difference to the climate if they are 10 times more expensive than the unsustainable products they're attempting to replace. Lowie Bricks come to the market at the same price, or sometimes even cheaper than soft mud equivalents. In a world of volatile gas prices, unfired Lowie Bricks come with security of stability in price, which cannot be relied upon for gas-fired clay bricks. Just to side note off script ever so slightly, I just want to mention that that comment and the slide that you can now see up on the screen, they have, I can assure you, been in the presentation since we wrote it a year ago. They haven't been cynically and hastily shoved in to take advantage of current very worrying events. A significant proportion, as much as 30 to 40% of the cost of a brick, is attributable to energy consumption. And this is usually in the form of gas to fire the kiln. So this means that events such as the record gas prices of 2022 have a huge knock-on effect. They were followed by record brick prices in January 2023, when those increased costs were passed down the supply chain. Unforeseen increased production costs can be catastrophic halfway through a project. I don't really need to tell you guys that. There are many suppliers and developers who ran into real difficulties during this period. The founders of Lowie, with a background in brick finishing, were heavily infected by the increased price of their base bricks. In certain cases, they even had to lend money to their suppliers to keep the kilns running, pay their gas bills, and ensure their supply. Achieving greater price stability then became a guiding principle in the development of Lowie Bricks. Global fuel prices are subject to a range of environmental, commercial and political factors, and are therefore currently much more volatile than the other raw materials involved in clay and Lowie brick production. With their vibro-press production method, Lowie Bricks are not fired and use no fossil fuels, resulting in far greater price stability as well as the sustainability gains. We are currently available across 3 finishes, 3 colours, and we have 3 different size formats. So up on the screen now is the handmade version in the white, grey and grey. Lowie Handmade has the authentic look of a soft mud handmade brick. It's got textured with natural looking fissures designed to replicate genuine 19th century handmade bricks. The finish is pressed onto the face during production using 3D printed moulds made with actual handmade bricks. We use quite a large sample size there. So there's 100 in the sample size, and Lowie bricks can be laid. Lowie bricks, are solid, so they can be laid facing whichever way up, and therefore extending that pattern range quite significantly. With Lowie stock, we have the clean aesthetic of a soft mud sandy texture brick or a stock brick with a smooth finish. As with all the other textures, they're currently available in white, grey and grey colours. We have additional colours in development with red, orange and yellow next in line. We hope to be bringing these to the market very soon. And again, towards the end of the presentation, there'll be some images there as well. For Lowie tumbled, we take the handmade texture Lowie bricks and then we age them through the tumbling process. The vintage charm of the characterful chips and rounded edges gives a reclaimed feel to the brick. With Lowie linear, we have an elegant long format version which doesn't look out of place in high-end design projects. However, unlike most linear bricks, they're actually the same price as the standard size format. We create the texture in exactly the same way as the handmade version. It's a 3D printed model taken from a genuine handmade brick that gets stamped onto the face during the vibro-press stage of production. For standard UK metric size clay bricks, the emissions stand at 45.36 kilograms of CO2 per metre squared of brickwork. By comparison, the embodied carbon emissions for Lowie bricks in that same format is just 10.85 kilograms of CO2 per metre squared. And that's a reduction of 76.1%. For Lowie bricks manufactured to a depth of 80 mil, this figure is just 8.47 kilograms. And that's where we get that higher reduction figure of 81.3%. So these are currently available off the shelf in two formats. We have a Belgian size format of 210 by 50 that's manufactured to a depth of 80 mil. And then the linear range, 240 by 40, also gets manufactured to a depth of 80 mil. We can produce standard UK size bricks to a depth of 80 mil as well, therefore achieving that greater reduction figure. It would just mean that your headers and stretchers would no longer be modular. So you potentially still need some standard depth bricks for the corners or a cut brick to go in there in the corner. So to add that all data in the above table is calculated using the life cycle analysis of Lowie bricks conducted by Encon, a highly respected independent organisation supporting businesses in the transition to sustainability. What do these reductions mean in terms of actual carbon emissions saved? So to give you a little bit of context here, if you were looking at a project of 167 metres squared requiring 10,000 bricks, there would be a reduction of 5.75 tonnes of CO2. It's about the same as the emissions produced by driving a 1 litre Ford Puma ST around the circumference of the Earth. The emission savings of using 100,000 Lowie bricks instead of clay is 57.52 tonnes. That's about the same as the emissions produced by flying economy from Heathrow to Sydney, Australia, 38 times. If the project is for 500,000 bricks, the saving is over 287 tonnes. It's enough to offset the emissions of the average UK household for a period of 48 years. So I mentioned it briefly already, a unique feature of Lowie bricks is natural carbonation. So this is a process whereby the bricks absorb and store CO2 from the air surrounding the brick. It happens after construction, and it can take up to 30 years. The speed at which it happens is influenced by various different factors, such as the CO2 content in the air, the wind levels, and the air diffusivity of the brick itself. Weak hydroxide molecules within the brick's mass attach to CO2 molecules from the atmosphere, resulting in the formation of strong carbonates. And unlike with biological carbon capture, this method of storage is permanent. So if you knock a Lowie building down at the end of its functional life, grind it down into aggregate, put it in the road, or whatever you're going to do with it, then that CO2 will still be stored. Whereas, of course, when trees decompose, they release their carbon back into the atmosphere. Just to clarify, this is very much not me telling you not to plant trees. Please still plant trees whenever you can. Lowie bricks are designed with features that naturally accelerate this process, and when it's complete, 58% of the embodied emissions of the binding agent have been recovered. To put this in simple terms, building built in Lowie bricks will continue to absorb CO2 from the air for a period of up to 30 years after which time the process will be complete. So we'll take a slightly closer look at the life cycle analysis of Lowie Bricks now. So the emissions can be split up into 4 significant stages. The first and most carbon heavy stage is the extraction and refining of the raw materials. This is where the embodied CO2 emissions of the waste from steel production are counted, and at this point the emissions stand at 13.54 kilograms of CO2. It's followed by transport from the quarry to site. The third process is production of the bricks at the facility, and then lastly we have transportation to the building site, construction, and the functional lifetime, during which time the carbonation process takes place. And that's when the figure starts to drop back down, and when it's complete, the embodied CO2 of Lowie Bricks is reduced to 10.85 kilograms of CO2, less than that of the raw materials alone. The only source of emissions are the supply chain, energy consumption, and transport. Brief word on environmental performance declarations here. We are a very new company, and we have life cycle analysis. We have been accepted for an EPD, and we haven't got it yet. It's coming through this month in June, so we should have it very, very soon. The reason that we have an LCA already and not the EPD, when we first applied for the EPD, it was accepted, but they wouldn't allow us to count the additional carbon capture by carbonation. We've now had buildings standing long enough in Belgium that we've been able to remove bricks from a built facade after 1 year, again after 2 years, and then again after 3 years. We've had them tested for the amount of CO2, which has verified the trajectory to full carbonation after 30 years. So in terms of production emissions specifically, typically a traditional fired clay brick would first be put in heated drying chambers for a period of up to 3 or 4 days. Depends on various factors such as the size and thickness of the bricks, the ambient humidity, the drying method you're using. But it's generally done in a controlled drying chamber to prevent rapid moisture loss and kept at around 50 to 80 degrees C to avoid causing thermal stress or cracking. Lowie Bricks avoid this process altogether. With regard to firing, traditional clay bricks are baked at 1200 degrees C for 3 days, and Lowie Bricks, of course, avoid that process altogether as well. Overall, this means the CO2 emissions created specifically during the production process are 94.2% less than that of fired clay bricks. So production begins with locally sourced aggregates, reducing transportation emissions as much as possible. The mineral aggregate is transported on belts to the vibro-press machine, where the bricks are formed in bespoke moulds. As the name would suggest, this is done under immense pressure. It's actually 6,000 tons whilst they're vibrating. Bricks are then released from the moulds and then inspected for quality control before being transported to nearby shelving, where they are left to cure naturally. They reach 10 newtons crushing strength after 3 days, and they continue with that strength gain up to 20 newtons after 28 days. Again, completely natural curing, no need for any sort of heat in that process as well there. Composition of Lowie Bricks is key to their performance. The binders are comprised largely from residue streams from the steel industry, namely fly ash or slag. It includes clinker, which is a hard stony residue that is primarily composed of silica and alumina, and there are smaller amounts of other materials such as iron oxide and calcium oxide. The fine granulate of less than 2 millimeters allows for a monotonous structure, which is vital to achieving the traditional appearance, many of the technical properties such as the airflow to promote natural carbonation, and the high levels of moisture movement that allow for fast bonding with mortar. Lowie Bricks outperform traditional bricks in terms of moisture movement. In a dehydration test conducted over the course of 2 weeks, the humidity of Lowie Bricks reduced 50% faster than that of clay bricks. There are a few different advantages to this. Obviously, I've already mentioned it, but drying out quicker means they grip the mortar quicker, so it contributes to the laying rate. Reduced weight during transport, more significant than you might think. There are some clay brick factories that reduce their lorry load sizes during the winter months to account for the additional weight of stored moisture. They reach their final colour in a matter of days instead of months, and it's just generally easier to process and handle dry bricks on site. Frost resistance durability tests were conducted by an independent BLAC accredited lab. Tests involved the construction of a section of wall that undergoes and withstands 100 freeze-thaw cycles. All testing was passed, and Lowie Bricks are accredited with the best possible F2 rating. We carried on testing beyond the minimum. The longest tested in any particular section of wall was 160 freeze-thaw cycles, and again, absolutely no issues at all. So, no reason to think that Lowie Bricks can't go on and on and on. Once they're fully cured after 4 weeks, they get up to the strength gain, a crushing strength of 20 newtons. Soft mud clay bricks will vary in strength, depending on type, typically between 15 and 25 newtons. For non-load bearing external masonry, the minimal required compressive strength is 2 newtons, so we're comfortably exceeding that by about 10 times, and it gives you a resistance that will allow you to build a very tall building out of low bricks if you so choose. Thermal conductivity, of course, key parameter in assessing how well a brick resists heat flow. The lower the value, the better the insulation performance. So the water absorption rate, fine granular, high levels of air diffusivity enable solid Lowie bricks to achieve an insulation value equal or better than the majority of frogged and perforated clay bricks, and considerably better than dense concrete facing bricks. So for clay bricks, your K value generally ranges from 0.4 to 1, and for Lowie bricks, it's 0.62. So it's just in the better end of that range. Concrete bricks are poor insulators by comparison, typical thermal conductivity around 1.11. The thermal performance of Lowie bricks enables their use as slips in cladding systems, where of course even greater results can be achieved by the inclusion of additional dedicated insulation material. At the end of their functional life, Lowie bricks can be put to a variety of applications as crushed aggregate, including things like capping and sub-base layers, piling mats and hard-standing build-ups, working platforms, site hall roads, external workspace layers, all subject to compliance with SHW Clause 803 and BSM 13285. The end of life uses for Lowie bricks align with DEFRA's Resources and Waste Strategy 2018 and the Environmental Targets Regulations 2023. We've produced a comparison table as a quick reference guide to understand the similarities and differences between Lowie bricks, soft mud clay bricks, wire cut bricks, and concrete bricks. We'll make this table available after the presentation rather than reading through every last little statistic. The key points to note, again, we mentioned it already a couple of times, but the highest possible category of durability rating, F2 as standard. Size tolerance at T2 for Lowie bricks, in fact, because they're not fired, which is where all of the shrinkage and expansion would happen. Lowie bricks have extremely high dimensional stability, and also come with an A1 fire rating, a standard due to the absence of any combustible material. With Lowie bricks, all these properties are the same for every brick in the range. With clay and concrete bricks, they're probably going to vary from product to product, so you just need to check their declaration of performance to ensure you have the correct technical properties for use. What next for Lowie? So I mentioned it already, obviously we came to the market with an affordable, sustainable brick, but was obviously limited to the white, grey and grey colours at first. And we have obviously more colours in development, and these are just some prototype images of them. Apologies, we actually do have the buff yellow in production at the moment. So we will have proper full-on marketing images available very, very soon. And the bricks will be available for projects from September onwards. We expect to see some physical samples next month over here in the UK. Just to talk you through the images that you can see, so the buff, as I say, is already kind of being developed. That's a soft mud clay brick up the top here, and this is our sort of attempt to replicate it at the moment. In that image there, we're manually throwing on the white sand, which is part of that coloration. When it's kind of the process is finished, that will actually be mechanized, and therefore will hopefully it'll be a little bit more even. They are producing a red and an orange brick for us. There's still a little bit of work to be done on here. This is the sort of more recent colour you can see for the red orange version, which is kind of like it's halfway between the two and sort of a bit more of a pink. So we're just working with them to produce tones that are a little bit stronger for the UK. And then over here on the left, these are our early attempts at acrylic engobing. So we will be, obviously the majority of the bricks that are coming out at the moment are monotone versions, but these will allow us to produce multi-tonal versions. Again, just bear with us, these are our sort of early attempts here, so we think it would be a little bit more refined and a bit less garish by the time that we're actually bringing them to the market, just to give you an idea of what we're working on and what we can do. Just to also mention, obviously you can see here these are not through coloured. So the acrylic engraving multi-toner versions will probably not be through coloured. I know you can't see it, but the monotone versions will be through coloured. So it's produced with the use of coloured sand. So it'll enable us to achieve a through colour brick with those. But the multi versions will probably be just kind of faced coloured. Okay, so yeah, just really want to. We're nearly there, by the way, on the presentation bit. But just want to take you through some case studies to give you an idea of the impact of using Lowie Bricks in the project. So the very first project in the UK using Lowie Bricks was a housing development down in Folkestone. Originally, a white soft mud clay brick had been specified. The planning team recognised the positive impact they could make by switching to Lowie Bricks, and across 28 houses and 7,000 metres squared of brickwork, using Lowie Bricks saved 242 tonnes of CO2. We have a high-profile apartment block in North London, which went out to tender. The client was presented with Lowie white grey stock bricks alongside several soft mud options, and they were just looking for an authentic light grey stock brick, and they chose Lowie Bricks for their aesthetic alone. They were completely unaware of any difference in emissions at the time. They were extremely pleased. They were literally high-fiving and belly laughing in the meeting, and when we were able to inform them that their excellent choice was going to lead to a saving of 104 tonnes of CO2 emissions over the course of the project. This is actually in Cricklewood Broadway. We're very happy to meet people there. It's a public building. You can see it, and so if you do want to go and have a look at Lowie Bricks in work, it's a fantastic building. We're happy to supply the address. Come and meet you there. If you would like as well. We've included a couple of other images because we're very pleased and proud of this building and the CO2 that it's saved, and how the bricks look. Okay, so this is our certificate of carbon footprint awarded by Encon, who conducted our life cycle analysis. And again, it's just kind of including it in there. To kind of verify our claims, and please do for anyone based in the London area, or indeed anyone not, but who might want to come down, please do come and visit us at our showroom. It is, we're very keen to be a sort of sustainability hub for kind of anyone in the sustainable building sector. We have a big advantage in that at the moment we have quite a limited range. We're going to have to find somewhere to put all of the new colours, but at the moment we have got 6 metre walls of all the products in our range, so you can really get a feel for what they look like actually in work. We are situated between Borough and Elephant and Castle, and at the moment I would say, if it's okay, do contact us for an appointment, because we're not manned 100% of the time, but we do intend to be, so that there'll come a point when dropping in would be absolutely fine. Yeah, thank you very much everyone for listening to me to listening to me offline about Lowie Bricks, and any questions, I guess.
Thank you so much, Lawrence. It looks great, and great carbon savings as well. There was a question in the chat actually from Hugh. Can they be laid with mortar thicknesses other than 10 millimeters? I'm thinking of thinner beds.
Okay. Yes, I believe so. I don't know of any reason why not. I think we actually have some of the sort of thin tech glued version projects already standing in Belgium. So yeah, I think absolutely fine for thinner mortar joints if you want to go with those.
Okay. David's asking where they're manufactured.
Yes, apologies. So because essentially the presentation that I've just given is kind of based on a larger presentation, so it probably means that some of the things that I took out explain some bits and bobs that then just get referred to without an explanation in this current version. They're manufactured in Belgium. They're developed in Belgium, and they are currently still manufactured in Belgium. We have an overflow plant in northern France, which is reducing the transport a little bit, where they will make the base bricks for the UK. There are medium term. It's a two-stage production process. So we have the manufacture of the base bricks, and then we have the dipping. And the dipping, which gives them the sort of finishing layer, which has some coloration, some technical properties as well. Once we get up to a relatively modest level of demand, then we can bring the dipping process into the UK. So we'll manufacture those base bricks in northern France. They'll come across and then be dipped at our plant and then out to the site. So that is a sort of definite plan that will happen within the next couple of years, provided that the demand carries on as we expect it to. To actually manufacture the entire product in the UK, it's something we would love to do, and we are still researching that. What the stage we're at the moment is knowing whether we can. Basically, what's very, very key to a lot of the technical properties and to the appearance is the very fine granulate sand, less than 2 millimeters, and there has to be the right colours as well. If we can source that in the UK, then there's no reason why we can't make the bricks in the UK. If we can't source that, then even if we can manufacture in the UK, we're still going to be importing some of the raw materials. So whilst there might still be an economic benefit to it, there's less of a sustainability benefit to it. But yeah, so that's where we're at with at the moment. They're currently manufactured in Belgium. Transportation emissions are accounted for within the LCA up until the port. So we do still have, we're still doing a little bit of work on there just to measure up what our UK transport emissions would be versus UK clay bricks. Of course, there's still going to be some transportation there because the factories aren't going to be next to the site. But so there's still a tiny little bit of work to be done on that. But yeah, so currently manufacturing in Belgium, medium-term plans to bring parts of it into the UK.
That's great. I'll pick up Charlie's question next. Charlie just wants you to go over costs, if that's okay. She had screaming children at the start and may have missed some information. Relate to that. What's the key cost difference between a typical brick per metre squared and Lowie Bricks?
So it was really, really important to us to be able to launch. That was really, really part of the message that we wanted to get out. They are within the same kind of ballpark as their clay equivalents, essentially. We will always look to price projects individually, and obviously there is a little bit of volatility around a lot of things at the moment. But obviously that doesn't we have that very, very fortunate position of not really using any gas. We've still got some transportation costs, of course. Yeah, so for the whites, white greys and greys, we are in the sort of bracket, the ballpark of between 800 and 900 pounds per thousand. So that's kind of equivalent for white and grey clay bricks in the UK. That's part of the reason why we launched originally with those colours rather than the reds and yellows, because they are cheaper in the UK, reds, yellows and oranges. And our recipe is essentially the same. The base brick, the components that go into the base brick are pretty much the same, regardless of the colours. So it just meant that we needed to be a little bit more creative to be able to get reds and yellows into the same ballpark as the prices that they are in the UK. But that's what we're kind of where we're at now. So, but for the whites, white greys and greys, we're in that very much the same ballpark. Sometimes even cheaper than a lot of the products that you would see coming out. And I can't tell you about the reds and yellows yet because they're not out. But we hope that they will be kind of equivalent to their clay cousins.
That's great. Are you happy with that, Charlie? If you've got any secondary questions, then please feel free to.
Thank you.
Great. Yeah, Zach's asking if they can be used with lime-based mortar rather than cement mortar.
Yeah, they can. They are compatible with sort of all standard sort of mortars. Yeah,
That's good.
including lime.
Great. And Di, do we know how their appearance changes over the years with weathering and absorbing pollutants and stuff like that?
So we are a new production. We haven't got any buildings standing longer than about. I think the first was kind of finished in 2022. It might even have been early 2023. So that is obviously the unfortunate thing with a brand new product is that we can't. The only thing that we have got to sort of offer from that point of view is that they go through all of the same uh, testing that like a clay brick would before they're given their durability rating. It's the full finished project with product, not project, sorry, the full finished product with the coating on that's subjected to that durability testing. Generally, we do know that with lighter bricks, that I mean, the coating is a permanent part of the brick; it's a permanent bond. Lighter bricks used below the damp proof course will tend to just go a bit darker. So in those cases, we recommend treating them with a hydrophobic masonry sealant. Sorry, that's something that we didn't mention in that shorter version. You can use Lowie Bricks below DPC. You absolutely have all the technical properties to allow for use below DPC. But generally, with lighter bricks, they're going to be a bit more susceptible to build up of moss and dirt over time. So we recommend using a hydrophobic masonry sealant for bricks below DPC. And that will obviously have some impact on the weathering. But unfortunately, we don't have any real buildings or images to show you. All I can say is that the ones that are 4 years old in Belgium still look fantastic as far as I'm concerned.
That's great. Thanks. Di, do you have anything you wanted to add to that? Or you happy with that? All good. Okay, and Sophia's got a question. Are you able to produce for a large order? What's the biggest project you've produced the Lowie brick for anywhere?
It actually, so honestly, it is in fact our first UK order. Is our largest order. So that housing development in Folkestone is the largest single order that we've had so far. That's mainly down to a difference in the kind of market in Belgium and in the UK. UK is the second territory that they've launched in. A lot of confidence in that as a market for sustainable products. Really the kind of so I'm just looking back on so that was about 500,000 bricks. The order book that they took 400,000 in the end for that. So the Belgian projects tend to be one nice large house, or perhaps like a smallish sort of apartment block. So those are the biggest ones that we've done so far. But yeah, we're very comfortable producing at scale. We have capacity. Basically, our first target is to get up to our capacity for the UK, which is 20 million bricks as it stands at the moment. We're in the process of building a larger factory, like dedicated plant at the factory anyway, which will hugely increase our capacity. But at the moment, we have allocation for 20 million bricks. And our order book's not quite up there yet, so we want to get it up as soon as possible, and so then put the pressure on them to make some more. But yeah, we're absolutely happy with looking at projects of scale. Yeah.
Great. Does that answer your question, Sophia? Let us know if you want to add anything to that. Yeah, she's saying thank you. Great. So that completes the questions in the chat for now. Would anyone like to put their mic on and ask Lawrence anything or share any information about maybe a project they're looking at? Might think of a question after.
Yeah, absolutely. Obviously, you share my contact details with everyone anyway, but when you show it. So, yeah, if anyone thinks of anything afterwards, I'm a great one for this. I'm always walking downstairs and going, why on earth have I come down here? Having to go back upstairs to remember why I've gone downstairs. So, yeah, if anyone thinks of anything after, then yes, please do let us know if there are any specific projects you want to talk about. Then, of course, I'm very happy and hopefully can answer any questions you may have.
Great.
I was wondering whether the same product can be made into larger units to replace, I don't know, Portland stone or other something like that. Is that feasible?
It's so at the moment there are no immediate plans to look at essentially replacing anything like stone or anything like that. I don't know of any reason why not, but we haven't done any kind of sort of testing, and that's not on the immediate horizon. The thing that we've tried to do is specifically look at embodied carbon in brickwork. So basically just replacing. So bricks are this incredibly durable material that we love and should definitely be part of the sustainable conversation. It comes with a huge upfront carbon cost. And we just wanted a way to produce something as durable as that, has the same lifespan, but doesn't come with that upfront carbon cost. So that's kind of where we've gone with that. We've been asked previously about looking at like, can you replace blocks with them? It probably just wouldn't be cost effective, because part of the reason, a lot of what's gone into to producing these bricks is to make it a facing material and a beautiful facing material. So to have it as sort of kind of, like mainly structural, it's probably just not quite the right blend of materials. But there's no reason why potentially we couldn't adjust our recipe. But yeah, obviously the part of it has been to produce this brilliantly like modular brick. But no, it was interesting that you asked about stone, because I'd never really thought of it as going up against them and replacing stone, and where we would sit on the sustainability against that. Perhaps that is something for us to think about, but no immediate plans at the moment, and I don't know whether it would work. So that's something. If we find anything else about that, I'll be back in touch there.
Okay.
Thank you, Lawrence. Actually, Hugh's got another question. Are 80 mil thick bricks used in the same way as 102.5 mil bricks, i.e. as standard outer leaf? UK lintels, wall ties, etc. tend to be made for standard size.
Yeah, absolutely. So you can get adjustable fixings and things like that will enable you to use the 80 mil bricks. That we're not the only people looking at that type of thing. It's been that's been led by clay brick manufacturers. One of the only things that clay brick manufacturers can do to reduce their upfront CO2 is to reduce the thickness of the brick. So I think the push for sustainability meant people actually had a look at are we over engineering facades and things like this, and looked at what they could do to reduce to look at do we really need all of this in a one? I think that the idea was that essentially it had been specified as something that was a bit more than necessary. So it was kind of quite like, and again, our sort of 80 mil version is kind of just, as we were developing it, we realised that lots of other people were producing these thinner bricks. We thought, well, we can reduce the carbon even more, and we don't need any more than that. So that's kind of where it's gone from. There used to be some guidance from NHBC, I think, around the minimum thickness of a brick, which has just been removed as far as I'm aware. So they haven't really updated it and replaced it. They're just no longer said that you have to have a brick for that depth. But yeah, you need to look at adjustable water fixes. I think like Adcon, I know, are a company that do a lot of those type of things, so we can look at specific design aspects as well for on a project by project basis.
Yeah, so that sounds like a good chat to be had after the event, maybe, and on a specific project. Perfect. Thanks for your question, David. What about plans to replace concrete blocks, i.e. common blockwork, not a facing brick? Any plans there?
Yeah. So yeah, again, that the same sort of thing. Like potentially, there are no plans to at the moment because what we have put all kind of our energy into doing is producing something that works as a beautiful facing material, and have potentially made it more expensive than it would have necessarily needed to be for a concrete block. So it would be back to more development for anything like that. So no immediate plans at the moment, but yeah, there's no reason why the technology can be applied in the same manufacturing process.
Then maybe it's a case of watch this space and keep in touch. Great. All right. Does anyone else have any questions? Yeah. Okay. Hugh's got one. Does the increased water absorbency lead to greater weather penetration, and do you have any information on efflorescence?
I do. I thank you for asking, because it's a massive advantage of these bricks that I didn't mention in the presentation. They have minimal active soluble salts, so they basically don't effloresce. So that's one like really sort of positive aspect of the bricks. So the water absorption is quite carefully calibrated. Mentioned that they have they're dipped in a solution which has some technical properties. Now that is weather resistant, that solution. So it doesn't make them fully waterproof, not completely non-permeable. And the reason that they're not completely weatherproof is to essentially the cycle of water and air getting into and out of the brick is what makes the carbonation happen. So the absorption of CO2 after construction. Essentially what happens is, like, very sort of like tiny air in the brick essentially. The coating solution will only be applied to the faces that are going to end up exposed to the elements, so the rest of the faces are more breathable. So that allows air in. Water then will come in, small amounts of water will come in, which will push that air out once it's already absorbed a bunch of CO2. And then they will dry out very quickly again, bringing more air in, which can then, the bricks can then absorb that CO2. So that's partly that kind of cycle. The water absorption itself, as I say, is calibrated to it is 16% on the uncoated faces. So that means that they grip that mortar quite quickly. And then I say the uncoated faces also allow sort of breathability, but then the coated faces that are exposed to the elements are just a little bit more weather resistant, so you don't get like too much water in the brick and saturation. Realistically, if you've got any uncoated faces that are laid exposed, then they are going to discolor in that. They're going to go darker, and they're going to discolor in the same way that we think bricks below DPC will. Just to add that using a hydrophobic masonry sealant is purely from aesthetic point of view. There's no structural reason why you need to do that for bricks below DPC.
Great, thank you. So let's capture any final thoughts if anyone has anything. There's lots of people saying thank you, and nice pair of hands going up there.
I was very impressed. I wouldn't know how to do that.
Yeah, so there we go. There's another.
Thank you, Katharina.
The appreciation. We love that. Actually, just before we go, I just wanted to ask a quick question of our audience here. Can you see that poll coming up?
We can see it, Charlotte. Yeah.
You can. Fantastic. Which would be your preferred days to attend a free lunchtime CPD? Sorry, this is just, sorry, Lawrence.
That's quite a lot. I'm interested in the answer because my Wednesdays are very, very booked up for quite a long time.
Okay. Yeah, just wondering what's a good day for people to lunch and learn.
Mondays, apparently.
Monday's looking good. Yeah, interesting. Wonderful. Okay, so 100% have answered. It looks like Monday's quite popular, closely followed by Tuesday. Thanks, everyone. That's really helpful. Really appreciate that. So I guess it's time to say thank you very much to Lawrence. Really interesting, really great pioneering work that you guys are doing. I'm sure there's lots of people on the call who may have some further follow-up questions and maybe want to have a chat with you at some point. So thank you everyone for coming tonight. We are a few minutes early finishing. All right, Henry's saying it's an exciting product range. Brilliant, thank you. Good to know that.
Thank you to everyone for your comments. That's been really lovely.
Really appreciate you joining us tonight, Lawrence, and wishing everyone a good evening. Let you all go and get your dinner now. And yeah, hope to have you back at some point, Lawrence. Thank you so much.
Thank you very much for having me.
And just to say, recordings and slides are available after the event as usual. So we'll make sure you get hold of those. And yeah, hopefully you'll pick up a conversation with Lawrence at some point. All right. Thank you so much.
Thank you. Goodbye, everyone.
Bye.
Lawrence, stay on if you'd like, and we'll just have a quick chat. All right. Thanks, everyone.